In this problem, students will have to use what they know about perfect squares to plot numbers on a number line. And some of these numbers will be square roots that are not perfect squares. So one of the things students need to learn and kind of help maybe even memorize are their perfect squares. So when students are learning about square numbers, they learn that a perfect square is a perfect square because the length times the width is the same number. So this is a 2 by 2, and then we have our 3 by 3, and then our 4 by 4, and practicing actually exploring with this and understanding what a perfect square is a nice way for students to learn their squares. So this would be a 2 by 2, so altogether this is an area of 4. 3 times 3, altogether that is an area of 9. 4 times 4, altogether that's an area of 16. So we call these perfect squares, and students should memorize up through 10 at least. It's a good strategy because they're benchmark numbers and help us with numbers that are not perfect squares. Now, the inverse of 2 to the second power, 3 to the second power is the square root of. So if someone says, what is the square root of 4? They're asking, what's the length and the width? And again, it's going to be the same number, so we just say 2. What is the square root of 9? 3 times 3, we just say 3. So understanding perfect squares is what will help students organize numbers that are not perfect squares. So in this particular problem, the first thing students may want to do is sort the numbers that are obvious. So I see that I have a 6 here, so that's easy to place on my number line. And I see that I have 7.5. That's also pretty easy to place on my number line. So those two numbers are going to fall right here and right here, halfway between 7 and 8. Okay? So that's pretty much done. Now, the other numbers are a little bit trickier, but maybe students will recognize that there is a perfect square there. So if we go back to our little list, we see 8 to the second power is the square root of 64. The square root of 8 times 8 is 64, so the square root of 64 would be 8. So then they can go, oh, well, here's a perfect square. I can put that on the number line. So I can take 64 and put it right over the 8. And that means I have square root of 64 is 8. Now, the other two are not going to fall exactly on a perfect square. If students have those memorized, they'll know that the square root of 40 and the square root of 83 are not perfect squares. So they can go back to their list if they kind of list them out, and they can say, all right, well, what do I know? Well, if I slide this over, I can see square root of 40, and I can look down my list and I see square root of 49. That's a little too high. Square root of 49, that would be 7 times 7. 7 times 7 is 49. But the square root of 36 is 6. 6 times 6 is 36. So I know that it's going to be somewhere between 6 and 7, but probably a little bit closer to 7. Maybe somewhere in the middle here. And again, students can get really exact. They can even break this down into tenths. But if we're just estimating 36, 6 times 6 is 36, 7 times 7 is 49. So it's going to be somewhere right here in the middle. So I'm going to mark it right here. And since our number line is not labeled, it's an estimate. Okay, so we have 83. So 83, what will we do with that one? So again, we can come back over to our list, and I see 9 times 9 is 81. The square root of 81 is 9. Well, I have 83. That is just over 81. So then I know that if I want to put this on the number line, it's going to go just after 9. It's not going to be 9 because 9 would be 81, but I can mark it very close here to 9. It's not about the halfway mark. It's more like about here. Okay? Square root of 81 is 9, so I'm pretty close. And students might even want to write their benchmarks underneath. So we know that 9 is the square root of 81. The square root of 64 is already here. Square root of 49. Okay. This is another good strategy just to help students with estimating. And 25. So teachers may encourage students to do this before they sort, just so they can see if they know, or if they have notes, if they have a list, and they can refer back. This will help them put numbers on a number line.